Everyone. We're going to talk about applications of machine learning in streaming video. I think everyone knows that machine learning is a growing thing. It might be a huge revolution that is getting started. Might be something else. I come from San Francisco, kind of live in that sort of VC world down there. And if you want to raise money today, your best bet is to find like an existing business model and add blockchain to it. But your second best option is to find an existing business model and add machine learning to it. So what we're going to talk about today is what is real in machine learning, what's hype, how does machine learning today affect streaming video, and how will machine learning affect streaming video as time goes on. So just kind of a quick agenda. We're going to start with introductions, introduce this excellent panel of experts here. Everyone's going to do a short kind of 5-minute lightning talk talking about their experience, about some things that they are working on or find interesting in machine learning. We'll go to some discussion, and then hopefully we'll have some time for Q&A from the audience as well. Sound good? All right, so we'll start with introductions. I'm John Dahl. I'm co-founder and CEO of a company called Mux. Kind of why I'm here and thinking about this is we have two products. Our first product is called Mux Data, and it's a QoE platform for video performance monitoring. So if you saw Matt Fisher's talk recently, we do, as a product, a lot of what Matt is doing right now at Vimeo. But within that product, we have a machine learning model that does anomaly detection. Machine learning is one useful way of doing something like that, alerting. Our second product that my colleague will talk a little bit more about, it's called Mux Video, which is a platform for video encoding and streaming. And there we use machine learning in a model that does per title encoding. So we analyze videos and make different decisions about how to encode them based on that. So that's me. Next is Colin Wilms.
Sure. So I am SVP Cloud at Deluxe. And do you want me to do the 5 minutes?
No, just introduce yourself to start, and then we'll go from there.
Sure. So Deluxe is comprised of a number of different entities, if you will, across creative, distribution, and also technology. And as part of this whole migration of infrastructure to cloud, et cetera, we're combining a lot of these efforts and basically landing everything on, say, AWS, GCP, et cetera. But our biggest, at least the thing that we're driving toward, is how can we take advantage of things like ML or AI or managed services, or build it ourselves through data science to sort of enhance this platform that we have.
Hi, I'm Pankaj. I am a part of the video team at Facebook. The challenge that we have is that of scale, right? People upload their memories onto the platform, and you end up sharing let's say your memory with some family who do not have a great connectivity. So how do you handle a case where there is a huge variety of in the quality of the content that gets ingested in, and then a massive diversity in the consumption, from gigabit connectivity to somebody with barely a 3G connectivity, and with the number of variables and number of these sessions, it feels like an area which is ripe for machine learning to go and help us build better experiences.
Hi, I'm Ben Dodson. I'm a data scientist at Mux, and Mux hasn't been around too long, about 2 years. So it's an interesting problem to be able to build machine learning with, in tandem, a new product like Mux Video, because unlike Facebook, in which you have this huge product that you might be inserting machine learning into at later points after the product's been built, we are really trying to build the product strategically together with AI, and that's a different challenge. Certainly not at as huge of a scale. And so it's a very interesting problem to solve as well.
I'm Zach Shenker, Director of Video Optimization and Experience at CBS Interactive. as part of the larger central video technology group, we provide a suite of sort of shared video products and services to our 25 different brands at CBS Interactive to enable them to effectively deliver video. And really part of the focus now for my team is how do we set a baseline of where experience is today? How do we collect data on what the real experience users are having, all the components from players and client side, as well as throughout the encoding, delivery, and other parts of the video stack, so that we really have a good understanding of what experience we're providing today, and then mining through that data to understand how we can optimize and improve experience. I believe there's a lot of opportunities as we get into more of these data sets to use machine learning to help with a number of projects.
Perfect. So we're going to go now to everyone has share a little more detail about what they're doing and how they're using machine learning and kind of their perspective, and then we'll go from there.
Yeah, so at least from like my perspective, I think if you look across all of us, at least the side that we're concentrating from the Deluxe perspective, machine learning on is more on the supply chain, ingest, dailies, VFX, etc. So it's really starting from here and then almost moving down the chain for distribution. So I'd say, we have these different divisions within the company. Those of you that aren't familiar with Deluxe, if you look at pretty much any movie out there and you roll to the end credits, you'll see something like Color by Deluxe. But at least on the creative side and the distribution side, from creative perspective, there are a lot of ML avenues we're looking at, things like color transfer for artists, for example. In other words, the stylistic intent of the coloring of a feature film. How do we have one expert do that and then transfer it to the rest of the frames? The trick there is that it's a mathematical one-way function to do this in many use cases, just by nature of the way that the color is, say the parameters are given to post houses, etc. So that's one avenue, right? The other avenue, and that's very much in its own realm, if you will. One of the other avenues is how do we do distribution and apply ML to that? So we distribute about 5+ petabytes a month of content. So almost anything that you've watched, if it's in theaters or if it's on the OTT service, has been touched by Deluxe somewhere in that supply chain. So supply chain's really aggregation, making avails available, and then doing things like metadata augmentation. But the main applicability of things like ML here are to decrease the SLAs to be able to distribute content to multiple endpoints. And by way of that is processing large files in extreme volume. So if we do thousands of titles a month, each one of those titles could have up to 10,000 assets, and that could be 140 different language tracks, audio tracks, etc. So we're applying to ML to things like if I ingest a new piece of content from a studio for distribution, how do I do auto conformance of audio tracks? In other words, if the language is in a different language, but I can detect things like door closes or different things within that full video track, can I then auto-align that to the primary conformance group and make that ready for distribution in multiple languages? So that's one use case where ML is one option, but we also have this challenge in that I'd say a lot of the things we deal with require absolutes instead of indeterminate judgments. So if you look at, say, when we do spectrogram analysis, etc., we're not looking for like an 80th percentile in confidence like that a deep learning algorithm would give you. We have to achieve about 99 or 99.9. And if we can't achieve that, a person has to come back into the equation. So a lot of what we deal with is either we look at implementing a specific ML function and we'll build it ourselves. We'll use some managed services like cloud providers will provide things, off the shelf pre-trained models. We'll use some of those as well. But in many use cases, our data science team will actually move the needle towards things like applied mathematics, spectral analysis, audio waveform analysis, etc. So it becomes a method of, can I efficiently utilize ML, or am I better suited for my business for automation at that scale to actually move that across to something for, like, say, applied mathematics or just code per se. So that's our biggest challenge there, given the volume of files and the volume of content that we process on even like an hour-by-hour basis. But that's supply chain and creative, right? So I guess the thing that I just want to put across to everyone is that there's a huge difference between these two approaches to using ML, if you will. And I guess our overall encompassing complexities that we're trying to build something that can be usable for any one of these use cases. So we've basically built a platform internally that our data scientists can use to apply these solutions across whatever one of these problems we may have.
So, like, I want to touch back on the point, like, I talked about scale, but before I jump into that, I think there are like various areas in video where you can actually use ML, right? So for example, one of the areas we heavily use is on personalizing the content, for you, like the relationships and your friends, all of those are important, but often at times you have to look at what's inside the video and getting that semantic understanding of the video to make sure that we align interest in people. So that's the whole aspect of personalizing ranking, where ML gets very heavily used in our ecosystem across the family of products. The area which is near and dear to me is video processing and transcoding, where, as I said, scale is a challenge for us. We have to maintain the fidelity of the content. We have to preserve people's memories, and at that scale, even Facebook, we don't have infinitely big data center. So often it's getting the quality and managing the compute at the same time. The one thing that we learned while doing this is, or something we observed, is video processing has historically been something where we used heuristics. We did some certain things and we observed it works on most content, and then we codified those in certain rules in our system. And then what we are observing, not just from video, but all the other domains, is most of the times that the ML system that we are building are significantly better than the heuristics that we had built over time. So in fact, few years ago, we launched the ML system. It gave us 20% better compression on the sort of the state of the art we had at that time. And the other thing that is very exciting that is happening is these gains are additive on top of whatever is happening in the codec and compression area. So the gains are not eating into each other. So as codecs improve, and ML, whatever work you do, if it's codec agnostic, then the gains just are on top of the hard work that all the standards body AV1 and the others are doing.
So I want to talk about how, as ML has become more powerful over the past few years, you start wanting to approach every nail with your AI hammer. And that's certainly something that we experienced at Mux when we were building Mux Video at first. We knew we wanted to include per title encoding as part of it. So the Netflix way of doing per title encoding that they first discussed was using VMAF, or which is an image quality assessment to decide which is the optimal resolution at whatever bit rate. And that's a great process that works really well for Netflix. But if we were to replicate it for our business model, it would have been, one, too slow, and also too computationally expensive. And so our solution to this was to we knew that image quality assessment models existed using deep neural nets that outperform PSNR and SSIM. So we thought that maybe we can create an AI equivalent to VMAP that would be faster and cheaper for us to use. And that way we can actually include per tile encoding as part of Mux Video when it launched. And so as we started to build this, we started to run into all sorts of different problems. One was difficulty in creating a large enough training set, because in order to create a training set, we had to run VMAP jobs, because we were using VMAP as the target objective for this estimator. And another was because this is a full reference image quality assessor, and it took into account motion between the frames, there was millions and millions of parameters at the top level of the model, which made it very slow to train and very computationally expensive to train, which is the thing that we're trying to solve and avoid. But after weeks of training different types of models, it did start to converge to an acceptable level for certain types of videos. And so we thought we might be making progress, and then we would introduce a new video, and the model would become very unstable again. So it really wasn't working. This AI solution really wasn't working out at all. And then we started trying to look closer into why it was becoming unstable after converging towards an acceptable level. And we found that what it was doing wasn't really trying to identify the signals for image quality loss like we had hoped, but rather it had discovered strong correlations between types of content and the way that types of content lose their quality as you go down the bitrate ladder. And so our estimator wasn't built, was a pretty crappy content detector, because that's not how the architecture was designed, but it was still managing to tease out the signals as the strongest signals. So then we rebuilt the AI around more content detection, in which we're actually able to use a lot more resources around that as well, because that's a much more research space. There's a lot of open source models around that as well. And so we were able to use, for example, a YouTube database, as well as ImageNet, and use transfer learning to boost the training speed of our model. And so using that, we were able to essentially create a per tile solution that looks at what the type of content is, and instead of measuring directly the image quality loss from a frame, rather modeling what the convex hull looks like for those types of content, which ended up being a pretty good approximation of the VMAP convex hull. So we did end up solving the problem using an AI solution, but it wasn't the AI solution that we started off as. And so I think that's an important strategy as you approach these different problems, is not to view AI as a magical panacea that's going to solve whatever problem you throw at, but to do it strategically and to be willing to pivot around your AI strategy.
Cool. So at CBSI, and particularly on the central video team, we work across a lot of areas of the video stack. So we have some projects going on using machine learning applications for things like content recommendations when you get to the end of the video. We've gone through many sort of passes there of getting the right metadata, getting the right access to video content to help train with, to understand what really is in all the content, what's similarities to other contents, that we can make the right recommendations and personalization sort of suggestions. We've got other projects going on around thumbnail selection, picking the right thumbnail for each user, that we're also looking at. Both using internal solutions where it makes sense with our machine learning and data science team, but also leveraging off-the-shelf solutions from Amazon and Google, where you can run your video content through existing pre-trained models or pre-trained solutions and get out object recognition or scene detection or things like that. So I think overall we're a bit sort of earlier in our machine learning journey, where I think a lot of the problem that we're still trying to solve is really getting access to a clean data set, collecting all of the data that's really useful to us. A lot of that is also about building a better common data warehouse rather than having data across different vendor systems or different internal databases. Is being able to correlate video quality of experience data with encoding data, with the adaptive bitrate switching logs and data that we have there. So that we can really start to get to a point where we can understand all parts of the sort of end-to-end video workflow and start to then be able to use that collection of data in terms of classification, feeding into ML models. And I think there's still a lot of questions we're working through as you build bigger and bigger data sets of how we effectively classify the data for some of the different projects to really be able to feed into an ML model and get clean results out of. One of the projects I'm certainly been thinking through is as we're getting access to more logs from our CDNs and moving to multi-CDN environments, understanding cache effectiveness is particularly important when you're based on performance data, you're guessing that two CDNs are going to perform fairly similarly, but if one CDN has the object in cache for a user and the other doesn't, there can be significant penalties in going back to origin. So we're starting to sort of explore the potential for using real-time logging data and machine learning systems to start to sort of process through all of this data and train models to sort of help us really estimate and guess the probabilities of different CDNs having different objects in caches.
Perfect, great. All right, so first question for everyone here is really the basics. I don't think we need to spend too much time on this, but I think it'd be helpful to define machine learning. How does machine learning fit into other data or algorithmic approaches to solving problems? What makes something machine learning? What's the difference between machine learning and AI? Who wants to tackle that?
Take a stab at it. So I think there are times when you're looking at data and you're trying to get inferences, like draw those inferences, like from those data, and then trying to come up with set of rule of thumbs, that you codify in your systems. That is like, yes, you're using data, you're leveraging a valuable resource, but that doesn't make it a machine learning, right? There is you got some insights out of that. I think the two key aspects of machine learning is sort of the training part of it, and along with that goes an objective function that your system can actually go and target. It can't be one of those things where you just say, I'm going to take a look at it and see if this is good enough or not, right? You have to somehow figure out a way to give it a score. So
yeah, I think I would agree with that too. I'd say maybe there is a subset of machine learning in which like unsupervised learning in which if you're using a clustering algorithm,
yes.
something like that, you might not necessarily have a score that you're aiming for, but the vast majority of machine learning that people talk about, you have your objective, you have your training function, but it's also, I think, a lot more mystified than it should be. I think people use machine learning as it's a new discovery, whereas it's really not. It's basically anyone who has taken at the very, very lowest level of statistics has done machine learning, right? Linear regression is machine learning. And linear regression, there's nothing, it's just like arithmetic. And you could do it on using pen and paper if you just knew the steps. And so I think the idea when people talk about, do I need machine learning as part of my organization, it's just they make it sound like it's this cutting edge technology that would be difficult to integrate, whereas it's a very, very broad field and broad, very encompassing, and so you probably should integrate some level of it. and doesn't have to be like the cutting edge self-driving car level.
Yeah, I mean, the problem is it's been driven from like, this notion of artificial intelligence where it's really assisted intelligence, right? I mean, if you dumb it down, and you're exactly right. So all of the things that at least we deal with for problems are, how could we enhance this better than just trying to codify it and have a developer working on it, right? So if we can use some algorithm that enhances it in some way, shape, or fashion that a development team can't do against that, just because of either the dimensionality or complexity invites you to look at that from a different context. Like that's our approach, at least, for media supply chain, for looking at these, options as alternatives.
And I think there's some element there as well of how it helps to sort of scale to, working with much larger volumes of data, larger volumes of content that, would be difficult if we're trying to, develop something or for analyzing hundreds of thousands of assets, that it, provides a more standard way to kind of deal with a larger data set and a larger scale.
Yeah, I mean, it's like any other computing pattern, right? You have to have a plan to implement it. I think that's where most people look at it and they don't know the subject domain or the application domain or how it relates to the actual data you're processing. So it seems like a nebulous of complexity, but it really isn't if you plan it out. And to your point, at least one problem we have is when you have, up to 600 petabytes of data, how do you efficiently process that data, right? Mm-hmm. And often you cannot do that. You need to use traditional things like perceptual hashing and just pixel transformation instead of actually putting an applied model against it, just because of efficiency's sake. Yeah. So you really have to, it's attractive to want to pick the one just for the hype, but that often doesn't move the business use case forward.
Mm-hmm. Yeah, and I think that applies a lot in our use cases where, you also have large mezzanines, obviously nothing like what you deal with at supply chain level, but much larger than what you have at, on the delivery distribution side, and, 20 or 30 years or more, 80 years of back catalog that you might have content for that, has all of those sort of same problems of, how do you effectively measure and apply these models and machine learning algorithms across such large volumes of content? And in which cases is it actually worth the cost of doing that?
Yeah. If everything you're detecting is a VES, what's the use? What's the what's the point, right?
So there's obviously a lot of hype around machine learning right now, more than maybe 10 years ago. But as we've said, machine learning is not new. It's been around for a long time. What's happening right now? Is there like a machine learning revolution happening right now? Is it hype? If it is happening, why now and why not 10 or 20 years ago?
I don't see it as a revolution. I think maybe certain fields within machine learning, like specifically deep learning and neural networks, experience a bit of a revolution. Especially, so like I think, and it's interesting too, because in the past few years, the number of revolutionary discoveries I think has gone down. Like the big one, I think was back in 2012, when people like Geoffrey Hinton and Yang LeCun came up with convolutional networks. That was a major step forward, and then the introduction of LCMs. And the ability for us to now look at, take inputs with millions of parameters and sort of solve the recursive dimensionality problem that plagued a lot of machine learning problems before. Like those are huge steps forward. But I think now a lot of the work being done, more of the work being done sort of like at the forefront is around reinforcement learning now, rather than what was previously done around more images or like computer vision. But it's a lot more. The improvements there are now a lot more iterative, rather than continual revolutionary discoveries happening every year.
And like sidestepping the evolution, I think the gains are like fairly broad, like, across like, multiple use cases. Again, like going back to sort of encoding world, every time like you got like 10, 15, 20% like, better compression, you had to wait for the next iteration of the codec to like come to the market, right? Now I think like we have this an alternate, like where some like you're almost like sometimes like, leaping ahead in terms of generation, like, without needing like, an entire like, codec, like, where solid tools like, with VP9 like, are giving you great like, compression, like which people didn't think like, were possible, like, when they were creating VP9. So the gains are very, very real.
I think also some of the hype around ML is probably also being generated by it becoming a more accessible technology to a lot more people now. Now with all of the offerings from all the major cloud providers and products out there to give you access to a lot more GPU or even custom ASIC resources for training models and for predictions and tools that do make it can make it a lot simpler and easier to get started with the training and using ML systems. I think some of that is probably leading to a lot more interest and even more products where it's a lot more turnkey. You can Google have products now where you provide more of a training data set and they'll handle a lot more of actually building your ML models, or there's pre-trained models or more options out there that I think can get people started with machine learning approaches even without a data scientist in some cases, or with a much smaller in-house data science team to at least get started on machine learning projects. And I think that's interesting for a lot of more traditional companies.
Great. So getting into video and machine learning now, what are some of the success stories that you've seen of people using machine learning successfully to do something interesting or something they couldn't do as well as they could before without machine learning? Either firsthand or secondhand. We talked about compression and other kinds of optimizations, talked about metadata. What works right now?
I'll say just from like our use case, the ability to do, and this is something where we started off, and to a tangent, it's almost like the hype around ML, DL, etc. actually pushed our data science team to look at that as an option, and then ratchet it down to I'd say a way to do it without using ML. But just having that hype in the industry actually pushed us in that direction. But auto-conformance is something, as media assets land, being able to conform audio to video is something where it would be a whole bunch of people sitting in a facility manually loading these files and then conforming them and creating EDLs. So just that small use case in itself, just in terms of supply chain, being able to distribute to your iTunes, your Netflixes, etc., without impacting SLAs, without having people working on that, and it being fully automated is a pretty monumental change from what it was maybe 5 years ago, just from a tangential use case.
I think I keep going back to one of the interesting talk that YouTube did at Deluxe, where they used ML to identify users who are not sensitive to changes in quality. So when they decided like there's no point wasting people's bandwidth, like in expensive data plans by trying to serve them 720p or higher, like especially if they don't care about the quality, like might as well cap them to like something that is acceptable to most users. That I thought was fairly interesting.
I think it's VMAP itself, which I talked about earlier too, is the machine learning image quality metric, rather than directly measuring the performance of pixels. It uses a support vector machine as part of its algorithm, which is interesting.
And in fact, like what that does is it turns around that you can actually build more ML models which can target that as an objective function. So
Right.
ML helping ML out.
Yeah.
How about some any stories of machine learning gone wrong?
I think two come to mind most prominently for me. One is when what happened with Google Photos about 3 years ago when they were labeling pictures of black people as gorillas. That made the news quite a bit. And it's like, I don't think anyone at Google intentionally did that, obviously. But you know, it was a very offensive and costly mistake that was purely based off of the robustness of their ML models. And so even if you have a model that is something like 99.9% accurate, that 0.01% error can outweigh and all the correct labels that you were putting on before. And another one is, I think is pretty well known, that when Alexa, I think they've almost solved this, but there might be some differential still, that Alexa was much better, well, one, had a terrible time understanding anyone with an accent, but also was much worse at recognizing female voices and understanding female voices than male voices. And part of this was because during the training process of Alexa, they were using a lot of people who worked at Amazon within engineering, and there is a skew in terms of the training set was not gender balanced, which also might have been the same problem that resulted in what happened with Google Photos. And so things like that, in which I don't think anyone created those mistakes intentionally or did so maliciously, but results in really bad mistakes.
Yeah, I'd say one thing is autistic intent, right? So at least from creative side, if you look at, say, subtitle conversion via automatic, transcription, right, via ML or NLP, the one thing that happens there is that the intent of what people are saying in context of the picture is not accurately described by just translating the speech to text. So that's one thing that's not there yet. I'd say at least on the other end of the equation, if you're looking at say color transfer or style transfer for media, one of the other things that is not there yet, and that's just because things like object recognition algorithms are there to identify the edge boundaries and give you a confidence score of what object is in a scene. But things like color space as from the context of how, say, a man and a woman perceive it via their optical paths, there are autistic ways to these colorized films to make it more attractive to an audience if it's on the female side or the male side, by way of how they perceive colors, right? So we're sort of like at an impasse where we're getting the basics via, say, deep learning, but it hasn't moved at one level deeper than that yet. I don't know how and when it gets there, or if it should even get there. Maybe a bad idea. But these are two of the things that, at least from creative side at Deluxe, come up a lot as well.
And not necessarily bad at the scale that you are talking about, but ML does take some control away from you. Sometimes it becomes hard to reason if you are ranking something in the 1 to 10, then why is some piece of content not in top 10, right? So all you can do is agree upon hey, this is the right metric we should go after. But other than that, it's becomes challenging to stay predictable beyond that unless you're willing to go experiment with different models or further continue to refining your objective function.
Yeah, and I think sometimes, as we work with a lot of different business units, and sometimes it's different teams of a business unit, are they more business focused? Are they more engineering focused? Getting everyone to agree on, KPIs and what you're measuring as, the effectiveness of a project, say, be it recommendations. We've had times of different businesses comparing both internal machine learning recommendation models with recommendation models from external vendors, and different groups were sort of looking at different metrics around engagement and watch times, and I think it's really important when you're evaluating different tools and different models to really understand and make sure everyone's kind of measuring the result in the same way.
Great. I think we have time for just one or two more questions. Any audience? Anyone in the audience have a question they want to do?
So regarding personalization and recommendation type stuff with video, like for example, CPS Interactive or Facebook, I upload my son's choir chorus video, and I go to Content upload video, and then I watch one of tea recipe videos. Are you gap capturing metadata information about my video experiences that you could then better help recommend things? If you are looking at content copyrights for the upload video and let me know I can't use it, are you looking at using potentially machine learning to better help make recommendations and personalizing my experience on your site?
So the fingerprinting the content and personalizing and recommendation are sort of, even in ML, very two different fields, and the way you do it is very, very, very different specialization. So doing one doesn't necessarily mean you actually extracted very meaningful information from one that you can apply to the other, right? So, but then we do take a look at what I think the relationships play into this. Your interests either explicit or implicit do play into what gets surfaced to you.
Yeah, I definitely agree with that. I think that, as well as sort of having that sort of understanding of, what's in the content, based on metadata, or actually, doing any feature extraction or detection within a video, within images, it, can then kind of be combined with feedback loops that, we get from the user, based on what pages you've visited, what videos you've watched before, what properties you've visited, things like that, can all kind of feed together in how we personalize and recommend content.
Anyone else?
I was just curious to know if you could, since I'm co-chair, I know to have you repeat the question so it's on the recording. Can you comment about just what tooling is available now? I mean, you were talking about demystifying the whole process. Like, I have this vision of computer scientists with PhD coming up with working all night on crazy, software to get all of this gathering done. Are there open frameworks that you can use on top of OpenCV that, I imagine, OpenCV's been around a long time, so there's, a natural evolution, I would feel, of sort of how to deal with massive amounts of data that, say, if I wanted to play around with something, is it, if I know computer science, how easy is it to get started to do this kind of stuff?
Pretty easy.
So repeating the question, what is the tooling available to make this stuff accessible today?
I mean, I can describe what we have, right? So we're trying to create, or at least our data science team is small, so 6 to 8 people, and our platform architecture team is small. At least for this specific thing, everything we have running is on top of AWS. So we'll typically look at, can this problem be solved by a managed service? Is this something that doesn't need applied engineering to solve the problem? Can you use recognition and augment it with something else, for example, right? Utilize that, store your data blob somewhere, and then augment the data elsewhere. If it's these other type of specialized use cases we have, it's going to be things like we write a lot of code in Go, we use Python, we use C++. We use things like OpenCV, glib for spectral analysis, right? There are a lot of good toolkits out there that you can use without even having to go jump into like the TensorFlow or other avenues, right? So they will do a lot of those pre-baked things for you. They won't do them accurately or well, but you can at least solve the problem and then go, is this good enough for me with the engineering effort I've put to it? No, it's not. Okay, we need data science applied to this as well. And I think after you iterate that a couple times, you actually start to solve the problem from the perspective of like, what's the context, the business context? What is the math problem we're trying to solve? Is this something a good data science team will actually try and not use ML and AI? They'll try solve it with traditional mechanisms because they know that, like, say, compute density is far higher to solve that problem at scale, right? Like we particularly have. I'm sure for like the rest, the use cases are different, but that's sort of our encompassing toolkit, if you will.
Yeah, I think it really depends on the use case, but I have seen like very few use cases in which there aren't like frameworks and toolkits out there available. A really nice thing is that a lot of the top places where research is happening are those companies or universities are also open sourcing their code or creating toolkits for developers to use. You know, probably Google, more than any other company in the world, is doing more AI research and releasing more open source AI tools to help the developer community. And a lot of the stuff that they open source too, you know, might not be their most cutting edge stuff, but you know, if you're a year behind Google, then you're in pretty good shape.
All right, I think we are out of time. So thanks everyone for coming. We'll stick around up here if you have any more questions. Thanks.